Good morning. In continuation to yesterday's talk, we have been dealing with the permanent way and its cross section. And we have seen the various components such as ballast, the sleeper, and the rail tightly fastened to the sleepers. Ballast on a firm ground on a trapezoidal shape. This structure of the permanent way is exposed to sun and rain. So during heavy rain, even though the ballast facilitates drainage, no water will get clogged there, it will facilitate drainage provided the side drains facility is not clogged. And during the elevated embankment area, the natural gravity will take care of the drainage. But there may be instances where the ballast will be on the natural ground, cutting across the ground, by which can be an excessive ponding of water on one side with respect to the other. And suppose this water enters laterally to the ballast with high velocity and quantity, there is every chance of this ballast washing away. Washing away of ballast means sinking of the rail, and derailment is obvious. So in the case of railway systems, daily maintenance on day-to-day basis, monitoring, and there is a very active system of maintaining, monitoring, managing the permanent way under the guidance of the permanent way inspector, PWI, permanent way inspector, a team of people with a rolling vehicle on the rails. They will monitor, they will check and see that the ballast, the sleepers, the fish plates, I told you yesterday, fish plates, they join two rails. And wherever there is loose ballast, they will compact it, adding more ballast to that. And the maintenance has to be on a very regular basis. The permanent way team will inspect the quality of the rails too. And the rails, over the rails, all wagons or bogies, including the engine, are called rolling stock. They are called rolling stock. So these rolling stock are running over the rail by way of flanged wheels. Flanged wheels means the wheel will have an inner flange. Outer flange will not be there. The wheel will have an inner flange to avoid coming out of the rail or derailment. To avoid derailment, you have inner flanged. Flange means there in the inner diameter, you can see, will be more compared to the outer diameter. So flanged wheels, and you have bogies. We told you the traction starting from steam engine, diesel. Now you have electric traction, for which at the top of the roof, of the train, with proper insulation of rubber pads, you will have a lever having two arms connected to the electric line. That electric line, overhead cable, electric line will be running. To that, this arm, upper arm will be connected, and that is called the pantograph. That is called the pantograph. That pantograph, then the bogies, the doors, heating and ventilation system, sanitary system, then the gangways, then the engine, then a compressor. All these things are the peripheral components of a rolling stock. Number of bogies. Bogies may be for transfer of goods or for transfer of passengers, both. So the rails, these inner flanged wheels over which you have the rolling stock. And nowadays the electric traction is very prominent and popular. You have a new additional electrical connectivity to the engine by the way of a panel. So the railway structure, you have a permanent way on which you have the rolling stock. That's the thing. Then, as you have the geometrical designs in highways, you have geometrical designs we have seen, things. Here also, you have geometrical designs, especially for the curves. Geometrical designs for curves, geometrical designs for vertical curves, then geometrical design for super elevation. Super elevation you have for railways. For transition curves too. There may be transition curves also. So there will be geometrical design. Then there will be for gradient. The maximum gradient allowed is called a ruling gradient. So geometrical design for the longitudinal gradient, geometrical design for horizontal and vertical curves, and geometrical design for super elevation. Those are all the civil engineering part of it. All these implementations of the rail system, then as I told you, the bogies and other things, it is a stream of mechanical engineering. Once the permanent way is over, then the civil engineer has to look into only the maintenance of the permanent way. Maintenance of the permanent way may be under the purview of civil engineering, but maintenance of the management of the traffic, control of the traffic, all will be on mechanical, electrical, electronics, and communication engineering. So nowadays, the smart rail systems of almost or even fully automated systems. So the role of communication, electronics and communication plays a very important role in the safe transportation of the rolling stock over the rails. Incidentally, the railway industry, railway ministry and the communication ministry has been coupled now, probably because in India, during the latest reshuffle, probably because this communication plays a very important role in governing an efficient railway system. Then in addition to the main parallel rails, you have auxiliary rails. One such auxiliary rail is known as guide rail or check rail. Guide rail or check rail. Usually the check rails will be there on bridges. In the bridges you will have check rails. Then on crossings of roads, you will have check rails. And whenever there is going to, the rails are going to cross each other, you will have guide rails. These two main rails are called stock rails. since the rolling stock is going over that, they can be called as stock rails. Then you have the guide rails or the check rails. Check, to arrest derailment, the wheel coming out of the stock rail. Then you have various level crossing. Very often you come across level crossing. During the development of any country, overbridges are being constructed. By constructing the overbridges, you minimize the collision of vehicles. So wherever possible, in a developed country or developing country, construction of overbridge has become common. If an overbridge is said to be constructed on a level cross means both are on the same level. The rail line, the railroad and the road are crossing each other. At that time, it will be either a manual control, manually controlling level crosses. You will put the gate either in this way or in this way. A manually controlled level crossing. Or you will be using levers, a mechanically controlled level crossing. Mechanically controlled level crossing. Now it has got the next extent known as the electrically controlled level crossing. Electrically controlled. The latest is the electronically controlled level crossing. Electronically controlled. So you have all these in our largest railway system in India. You have manually operated, mechanically operated, electrically operated, and electronically operated crossing systems. So level crossing system is an important, unavoidable support system for the safe running of the rolling stock without collision in the orthogonal directions of vehicles. Then another thing is called the signals and interlocking. Signals and interlocking. Obviously, the word signal itself giving signal to the driver. Driver should know whether to proceed or not, whether to stop or not, or whether to go with little speed or greater speed, or without any of the can I proceed with the allowable maximum speed. So those things, the stream, even though it is not the total thing is not done by civil engineering. This is a system controlled by mechanical engineering, electrical engineering, and electronics engineering. You have smart systems now, smart signaling and interlocking systems. So interlocking means once the level crossing is closed, once the key is put, then it is interlocked. Once the key is taken out, that is possible only after the train has gone or crossed the level cross. Various types of signals are available with various color codes, starting from manual systems. Flag, green flag, proceed. Red flag, don't proceed. That will be there for the daytime. During night time, you will have the light in which you will have a red slit and a green slit. Just to change the red slit and green slit, you can, the driver. So those things are governed at the station points. At the station points, it is governed. The driver is given all informations well advanced so that accidents can be avoided. Collision can be avoided. Because more rails at a time, more rails are running on the same track. So the distance, the safe distance between them had to be maintained. How this safe distance between them is maintained That is only by the signaling process, the interlocking process. At the distance is maintained. We'll continue tomorrow. Thank you very much. God bless.